So this is a video about finding the capacity of a cylinder in liters. So let's imagine we have a massive cylinder. Here's the giant cylinder, and we're going to make it quite big. In fact, it's so big that this is the size of a tree. So there's a bit of a comparison of the size of it. And here is some information about this giant cylinder that fell from the sky. It's even cracked the earth. That's how heavy it is. So here's our cylinder. So the diameter of this cylinder, so from here to here, looks like it would be about 37 meters from there to there. So it's pretty big. And the height is quite large. So from here down to here, the height is, we'll make it 56 meters. So it's really high. So 56 meters. So this is our information so far. What I do know is that if I was to zoom in, I do know that there's these walls inside, right? Because there's like a thickness to the walls of this cylinder. So if I was to do a bird's eye view, so let's snap over to here to like a bird's eye view. So if I was up in the sky and I was looking down on this cylinder and I had the lid off, we would see a thickness to the walls. So the walls are 0.5 meters. Not really thick, but they're 0.5 meters. And the base, so like the thickness down below here, based on some evidence and some research, we found out that the base, which is like the thickness of the fluorine, so we'll maybe call it fluorine, we could call it base, we could call it lots of things, is 0.75 meters thick. So if you were to look inside the cylinder, you would see that that's that thickness. There's also a lid that's also on top. There's like a cap, like it's sealed, welded shut. So the lid is 0.5 meters in thickness. So really what that means is there are two cylinders, right? So there's an outside cylinder, and then there's a kind of a cylinder on the inside. We're dealing with two cylindrical shapes. And this is the information that we're given. So what we need to do is we need to find the capacity of how much the cylinder holds. So what is the capacity? How much does this thing actually hold? But what we've learned is inside this cylinder, if I have like this X-ray vision and I can see inside the cylinder, I know that the cylinder is actually 65% full. So it's 65% full. And the liquid inside, as we have discovered, is actually orange juice. It's a massive, massive orange juice, bubbly orange juice with lots of sugar in it. It's crazy. It's been stored for over a year, just this massive amounts of orange juice. In fact, there's a whole bunch of orange juice trees here growing, and anyway, lots of orange juice in there. So how do we find out how much is in this? How much orange juice in liters? We need to find that out. And it was a rhetorical question, but Jocelyn wants to answer it anyway.
Oh.
Well, here's what we're going to do. So what I want to do is I want to, so Jocelyn, you can help me out. I know that, well, I do know, here's some things I know. I know volume equals pi r squared times height, but we also know capacity is pi r squared times height, right? So I'm going to just do capacity equals pi r squared times height. So I know that. That's some information I know. So this is just things I know. So what we can do is we can try to solve it down below here. So let's write some new information. What do we know about so I'm going to maybe put interior cylinder. How about I put that? Interior cylinder. Let's get some more information. What do we know about the diameter of the interior cylinder? Because we know the exterior cylinder is 37 meters, right? And we know the height is 56 meters, but inside it's slightly smaller. Jocelyn's going to try it out.
Yeah, so if the walls are 0.5 meters and it's on each side, that equals 1 meter. So then you subtract 1 meter from 37 meters, which will get you 56. So that the diameter is 36 meters.
Okay, so the diameter inside the inner circle is 36 meters. Emily, does that make sense? Okay. And, all right, so we have a slightly smaller cylinder, slightly smaller diameter. So from here to here is 36 meters, whereas the outside is 37 meters. Okay, what's the height? Because the height is somewhat smaller. We have less inside. So how do we find the height, Tegan?
You would subtract the bottom or the base of it, which would be 0.75.
Okay.
And then the cap is 0.5, and then that would equal 54.75.
So I'm doing 56 minus 0.75, and then I'm also taking away 0.5, right? And what do I get?
54.75.
Okay, so there's some rough notes over here. So we have 54.75 meters is the new height. That's pretty good. Okay, so now I think with that information we can actually solve the capacity at 100%. We can find out what it would be at 100%. So let's do that. So I'm going to now do capacity equals pi r squared, bless you, times height. Okay, so now I can start plugging in. In grade 8, we do 3.14. What's our radius? If the diameter is 36, what's our radius? 18, because it's going to be half. So 18 squared times our new height, which is 54.75. Okay, now we can just start plugging this in. So if I was to do 3.14 times 18 times 18, because that's the same as 18 squared, times 54.75, I get a whopping 55,700 and 0.46 cubic meters. But we're not done yet, right? We're not done yet. So that's cubic meters, but we're dealing with liquid. And we're also dealing with a 65% full container. So how do I convert? What are some other information? We know what?
That there are 1,000 liters of each cubic meter.
So 1 meter cubed is the same as 1,000 liters? Yes, so that's vital. So what do we need to do to this to get to liters?
We have to multiply it by 1,000.
Multiply it by...
That's not your answer.
That's okay. No, that's fine. So I'm going to do times 1,000 to get me liters. So do I need to use a calculator?
No.
What can I do? Kira, what do you think?
You just move the decimal.
Yep, just move the decimal place. So 55700, and then I just need 3 decimal places. So 460. Right? Do you guys agree? I just moved it 1, 2, 3. So that's it in liters, but we're not done yet. It's only 65% full. So how do I find 65% of 55,700,460 liters? Yes, Laura.
Is it divided
Laura,
by 0.65?
say it again.
Is it divided by 0?
Close. 65% of
Multiply.
multiply, right, Gibran? Right? You guys saw that? So I'm going to do 55,700,460 times 0.65. And that's going to get me, first let me just times this by 1,000, like we said. Okay, and now I'm going to times it by 0.65, and I get the capacity in liters of this orange juice is 36,205,299 liters. Final answer, yes. Okay. Question, yes, Emily.
This paper,
you can have this piece of paper. Okay, and that's the end of our video. Hooray!
That was a video.
That was a video.